Perfect. Give people a couple more minutes to hop in online, so now there's more coming. So right off the bat, Jack made a little bit of an oopsie yesterday and moved us on too quick, and there's a couple things we need to backtrack and cover first. So mostly so you guys can finish your homework. So we'll pick up PL stuff at the end of the lecture today, or pick it back up on Monday, or I mean Tuesday. Otherwise, I think what we'll do going forward is I still want to kind of keep functional programming covered every week. So we might do half of the lecture on Thursdays, be just kind of more functional programming concepts. Because I'd like you guys to be farther along with that than I would typically do. I think that's somewhere I could improve the class. So we'll probably do that on Thursday for half the time. Just kind of pick some of the grab bag of topics, get more practice with it, so you guys can kind of add that to your resumes of skills that you're able to do. So that'll be the full lecture today, probably, just because there's a couple things we need to kind of backtrack to. And then what else? Because of that, there's a few there. I did find an error in the standard library of the homework. It's minor, and you may not need to correct for it. But we have the definition of fold I gave you is actually incorrect on second glance. And we'll talk about why that is today. And you also need to know something about if then else in order to do the homework. So we'll talk about those two things today. And then I will actually probably extend the homework to Monday as well. So you guys will have the weekend to kind of make those corrections as needed. Some of you probably have figured it out, and others kind of got around it. It's definitely stuff you could have solved on your own, but it's not quite how we would have wanted you to do it. So we'll revisit those. And other than that, expect midterm next Friday. You'll have the full day to do it. There will be some kind of rolling office hours during the day. We will not walk you through problems. We can only answer like ambiguous kind of questions, stuff like that. What else? Keep up posting on Piazza. There's been a couple good posts the last few days. And if you're submitting, like, if you're not sure why your homework doesn't work, if you have a problem that you've mostly done, try and figure out a way to like ask the question without needing to post your code. Like I got a private question earlier today that would have been a great question for everyone to see. But because it had that student's solution there, which was almost entirely correct, or it actually might have been entirely correct, it couldn't be public. So be wary of that. If you can try and remove the code and describe the question, that would be awesome, because a bunch of other people had a similar question. It would have been good to just have that there. So, you know, if I'd forget who it was, but if you know, if it was you, it's not a problem. You can continue to post privately. I don't really care, but if you could, it'd be a big favor to everybody. I keep saying I'm going to post some writing online. I've had a rather unproductive week because I'm moving over the weekend. So that kind of sucked up a bunch of time. I'm hoping tomorrow morning to actually get that writing moved over to Canvas, or figure out, it needs some cleaning up before I can post. It's got a bunch of old material on it. So expect that sometime tomorrow, hopefully, or over the weekend. And then homework 3 will be posted sometime on Monday. That will be implementing our first interpreter of the small arithmetic language we were talking about. Yeah, I think that's all logistically I need to cover. I had my office hours today. Thanks for those that came. Managed to fill the whole time, which was really nice. Anything else to cover? A few of you in office hours, I told you we'd cover stuff in class today that were kind of responses to your questions. If at the end of class I don't quite hit on them, please remind me and I'll cover those. But I believe I have them all kind of on my lecture notes today. Any other questions or logistical type things before we get started? Nothing. Nothing at all? Cool. How's the homework going in general? Not bad. Good. So cool. Not horrible. I mean, I like to hear that. As long as it's not like the worst thing in the world, we're doing okay. Just Sweet. So let's jump into it. Yeah, so I goofed up the other day and told you that these two fold definitions were the same. They look like, and I even tried to show you they were the same. They're actually not quite the same, it turns out. And here's an example of why. So in these fold definitions, I ended up giving you a problem. I did some with the two, where it collapsed the value of lists, a list of numbers, down to a single number, right? That's all fine and well for stuff like that, where you're going from list to number. It would give you the same result. The problem here is that if you try and do that for lists, if you try and append lists, these two things actually give you different results. Okay, so let's see that. So here I will have a list 1, 2, or rather, I should start with actually what I'm doing with fold. So fold, and then my f will be the function. It takes a variable x, it takes an accumulator. The accumulator is going to be a list. And then it will append the singleton list of x onto the list we have so far. If you've done the homework, you might have written something pretty similar to this earlier today, or whenever you're doing the homework. Yeah, so if I write that down, I've got my function. Now I give it the empty list as a starting value. And let's give this the list 1, 2. And let's try to evaluate this, okay? So let's start with the first list definition. So I'll copy it down, or the first fold definition. And what does this equal? So I do fold on this, right? I have a cons case. And we know that the empty case gives you back the accumulator, that B value, right? Do this. Okay, so what does it tell me I need? I have a cons. So I have x is 1 here. And I get back f of x, so that's append. And that's the singleton list of 1 onto ACC. Here, ACC is the empty list. Wait, let me revisit that for a second. I don't like how that looks right off the bat. Oh, sorry. So it should do, yeah, f of x append onto the fold. Sorry, I was looking at the wrong definition. So onto fold, append empty list, and then 2 is the list we're giving it. Okay. Now we can keep running this forward. Now I keep the append around with 1. And now this fold, what does it produce? Okay, so it's another 2. So I've got append the singleton list of 2 onto the fold of append empty. Bump this into another line. And empty list. At this point, that last fold gives me that B value back, that base value. That's the empty list here. So now I have append of 1, append of 2, empty list, which we know from our append definition is going to be the list 1, 2. Okay, so all this is doing is really taking the list apart and putting it back together using append, right? It's not a whole lot of craziness going on. But let's look at that other definition of fold I gave you, the one that kind of uses an accumulator in the other APS style, and see what that gives us. So see what this guy gives us. So here, if I give it the same stuff, I have a fold duplicate, fold with that same function inside. Okay, here I look at this. Okay, well, I'll always get another fold because it's in that tail recursive APS style. I give it the same F. I'm just going to keep writing F. I'm not going to rewrite the lambda each time. Or actually, I'll keep writing append. We know it's a little bit more than just append, but just kind of keep that in mind. I'm cheating a little bit. And here, I accumulate everything inside that B term. So I do F of XB. So that's append of 1 and empty. And then I still have the list, singleton list of 2. Okay. Now let's reduce this. And I get fold of append with the list 1. Okay, so far so good. This kind of looks like what I should have so far. Okay, now let's do the next step. I have a cons 2, so we're looking at the same case. I'm going to get another fold back with the same F. And then I do append of the list of 2 and our B. Our B here is the list of singleton list of 1. And then I'm left with nothing over there. This reduces down to fold of append. And now I unfortunately have the list of 2, 1 and the empty list. With the empty list, we spit out that accumulator, that B value. So now I have the reversed list of 2 and 1. That's not what we would expect here, right? So the fold, unfortunately, that I said was the same is not actually the same. So that's a goof on my part. And unfortunately, the fold I gave you in your standard library is this wrong one. So we're going to send you out an updated version of the standard library. Hopefully it'll be tonight. I need to do it tonight. That has this updated fold function. So if you did problem, it's the big one with the filter with fold function where you're using fold to write the function. It's going to show up there, that error. So be aware of that. It's going to reverse the list. We don't want that. The problem here is that it's reversing whatever structure we had. It's kind of treating that list as a stack, but we want to treat it like a list, not a stack. We're kind of giving a little too much to our fold definition with this one. So we prefer this definition is correct. And these notes will be online too, tonight or tomorrow morning. This one is, we'll say, slightly incorrect. Because you can definitely do some stuff in that higher order function to re-reverse the list. You can definitely get around it, but we don't want to do that. It's incorrect as far as the standard fold definition goes. And fold is the same anywhere you go. If you go to other languages, find a fold, it's implemented like this, usually with some tricks to get around the tail recursion problem. There's a way to write this tail recursively. The way I showed you the other day is not it. So be aware of that. Any questions about that addenda? Addendum? Addenda would be more than one. Yeah. So addendum, about that addendum. I'm not seeing anything, chat, though. Keep typing if you do have a question. That's all I think I had to cover on fold. So just know that that problem might give you some extra trouble. You can still do it with the fold that's there. But you have to make stuff happen in a reverse order, which is kind of weird. So you can definitely, what you end up doing is if you use an append in that function, you switch around the arguments and you make the thing that you want first be second. It's really counterintuitive. Or you can just wait for me to send out the updated standard. Cool. The next thing we need to cover is a little concept called currying. But we'll get back to currying, so don't write that down yet. Gotcha. Instead, we'll write products. We need to talk about products first. Products are also called pairs. And because sometimes you have pairs with more than two things, we call them tuples as well. Hopefully everyone's encountered tuples before in some form. I think they're pretty common in Python nowadays. A question from John. If you made it work with the given fold function, will I need to rewrite my answer? No. So with that question, we'll be doing a more critical reading. And if you got it to work with the wrong fold function, that's fine. That's fine for us. We'll just kind of be careful with which standard library we use when we assess your problem. We'll actually end up probably renaming the new one and having to change some imports. So yeah, be aware. And whenever I send that out, I'll add some instructions with what to do to actually make it work. So cool. Products, pairs, tuples. Let's define a type for products. Okay, it's a type just like anything else. Okay, so we'll call this type, we'll give this type a little bit of a different name than what we've given other kind of type names for in the past. This time we'll use an operator or symbol that's infix to describe the type, and we'll use an X across. And we'll say this type is A cross B, where A and B are polymorphic. So that can be whatever A and B you want to give it. The name of the type is this cross thing. And then the constructor for this type. Does anyone want to take a guess at what the constructor, not the name of it, but what it will take as arguments? If it's a pair, we're trying to build a pair of things. Maybe a pair of things of type A and B, right? So here we have A, and we'll write the constructor here infix actually as well, A comma B. There's a reason for this. Okay, I could have also said maybe prod of AB, that would be more familiar to us probably, but we don't really like that definition. It's not as easy to use, it's too wordy. So we'll create this kind of shorthand notation instead. Everyone with me so far? Cool. So now I have a question. So if I wanted to construct a tuple, like with, say, a number and a Boolean, I could give that a type. So let's say I want to construct something with a number and a Boolean, and that would be of type nat cross bool. Can somebody give me an example, an instance of this type? There's a whole lot of them, actually, an infinite number, really. Or infinity times 2, really, if you think about it. Yeah, so Arthur says 1, and be careful here, we're not using the cross there, we're using the comma for the term, for the instances of it. It's 1 comma T, so 1 and true. You could also do like 5 and false. Actually, interestingly enough, this N cross B type, does anyone know another name for it? Interestingly enough. Or something it's very similar to. It is a tuple, John, but I'm trying to get actually specifically for nats and Booleans. We can use it to represent another type. So Graham had it, and I think whoever said online, you came through Warbled, but signed integers, right? So I could write, true is the sign, and the number is the number, right? So we could also say that like this is their fancy word, n cross b is approximately the integers, or actually this will typically mean is isomorphic to, which I don't actually expect you guys to remember that term yet. You might bring it back up, but it can represent the integers, right? That's more of an aside, but you could represent them that way if you wanted to. You could also create a type for the integers. But just know they're kind of equivalent. It's a fun fact to know. We could also create pairs of two numbers. So like I could have 2 and 4. What type would that have? What type does this term have? 2 and 4. Louder? Yeah, so that's a nat cross nat. I could also have tuples of functions. So if I wanted to put, say, plus here, and let's say and here, what type would this have? Well, let's type a plus. Nat to nat to nat. Yeah, and Arthur's coming with the full answer. It'd be a nat to nat to nat, and then a bool to bool to bool, right? So this would be nat, arrow, nat, arrow, nat, cross, bool, arrow, bool, arrow, bool. Cool, so we can kind of shove anything in there we want. Now let's talk about functions on products, right? So I'm going to write a function called f, and it's going to take a nat cross nat and give a nat. Okay. And I can pattern match on these tuples just like I would anything else, right? So I have f of, let's say, 0 and y equals y, and f of s of x and y is equal to s of plus xy. What do we, oh, I cheated there. Forget I wrote that part. F of xy. What do we call that function? Kind of gave it away a second ago. What? Plus. It's plus, right? So f is equivalent to plus, right? But here I gave it a tuple. It doesn't have the same, that arrow, arrow, arrow type. Here I gave it a tuple instead. That's kind of interesting, right? Could I convert a function that has a tuple kind of function type into one that's arrows, do you think? Seems like I can. We call this process, and here I'm going back to it, currying. Or in this case, it'd be if we went from arrows, or sorry, if we went to products to arrows, it would be called currying. And I can actually write a function to describe currying. So curry, the function, I'll catch up on writing real quick because I want to pull up the definition real quick to be sure I get this right. Bear with me, guys. Yeah, okay, I was doing that right. So actually, Curry's the conversion of the arrow to the product version. I had that the other way around. So here, I could take a function from A to B to B, or not A to B to B, A to B to C, and I could give you a function from A comma, or A cross B rather, to C. How might I do that? So let's define an argument. So I have that there, and I have this function here, f. Okay. Note that this is just a function again, so I can actually kind of remove those parentheses, right? Because we know the parentheses on the right-hand side don't really matter. And then I could also bring in and introduce that product as an argument, A comma B here. And that equals f of A, B. Everyone with me so far? Just double checking I gave that one in the right order. So this is actually, sorry, uncurry. I did have that flipped around. Whereas currying is going from the products to the arrow version. It's easy to get those mixed up. And so we could also define a function called curry, which is kind of the reverse, right? So I get a function that has type A cross B, arrow C. And then I have A arrow B arrow C as an output. Right? And for this one, remember, I can kind of remove those again. And I write curry, and I have f, some function here. And here, A and B are kind of, they're arguments. So I can have A and B, and all this is going to be f, and I give it the arguments A comma B, because it's expecting a product. And we know these are equivalent types. In some sense, these types are equivalent, right? The A arrow B arrow C and the A cross B arrow C. We know they're the same because I can go back and forth between the two with curry and uncurry. So we actually say those are isomorphic as well. You can convert between the two and there's no loss of information. Okay. Why is this useful? Did anyone get kind of hung up on their if then else definition in the homework? There are kind of too many parentheses in it. So if you guys remember in the homework, if then else, the tests for if then else are expecting a, let me think about it. It's expecting a bool, arrow, A, arrow, A, arrow, A. But up till now in Scala, we've actually been writing functions with products this whole time. And so how we've actually been writing if then else up till now, and how you guys were trying today, and I realized this in office hours today, was actually writing B cross A, arrow A. Okay, those are subtly different, right? And so a few people are getting problems like wrong number of arguments, or providing a type error because you're providing the wrong argument. You're providing a product where it was just expecting one thing. So know that these two aren't quite convertible automatically. You have to keep track of which one's doing which. Usually we'll write in this product style, but for higher order functions like or even polymorphic functions, I guess, with if then else, it makes sense to curry your arguments or uncurry them respectively. So if then else is one of these, and it could trip you up. So in Scala, if I had, say, a def if then else, our tests for that function are expecting you to write something like this, where you have, say, some Boolean B, and then to write a product, you'd put commas, but to curry, you actually put more parentheses. And then here I'd expect an X of type A and maybe a Y of type A. And those might be a product in the homework, I don't remember. But you can use parentheses to split those out. The homework will be due on Monday night after recitation for this reason, because Sakanya is going to go over this again. I believe it's in the notebook that we're going over on Monday. If not, it will be by then. And that's how you do that. That's why I feel you were probably having some issues writing if then else the other day. Yeah, so John's asking, do I prefer one version or the other? I prefer the arrow style. There are a lot of reasons for that. Partially it's because I don't come from a Scala background. I come from a Haskell background where everything uses arrows. We don't really use the product a whole lot. There are times when you do. So I prefer arrows in the kind of curried version as opposed to the product constructions. In Scala, it's typical to see the product version because it looks more like object-oriented programming. Either one is fine for me as long as your stuff passes the tests. That's kind of the rule. If you can pass the tests, if the function is correct, either one's fine. There are times when the tests will expect one or the other, and know that in the future there will be, because we're defining it on Monday, a curry and an uncurry function that you can just give your function to and it'll do it for you. So just know you can do this kind of as a function, even in Scala, convert between the two. So if you write the function in one way, but it's expecting the other, it's as easy as just calling curry or uncurry. Yeah.
So it is just essentially a neutral type, right?
For what?
Like X and Y.
Oh, for if then else. Yeah. So this is, I should note, this is also in Scala. Yeah, that's a polymorphic type. No, you can do that. That's the idea of polymorphic types. So there'd be that little square bracket off the front with the A in it. Yeah. And you should actually write it like that. A lot of people have been writing it just to pass the tests with nats. Note that that function is asking you to do it with just A's. So you can actually, for that problem, you can pass the test and still get points off. Yeah, the tests are not always quite a guarantee that you'll get all the points, because you can definitely write a function that just passed the test since we show you all the tests. Yeah, so make sure that, and it's as easy as changing that. A lot of people are writing nat, just change it to A. That easy. You know, when in doubt, always make sure it matches the type definition I give you. So, let's see.
Could you write the definition for the other style?
Oh yeah, so if then else, that's one way of writing it. How a lot of you are trying to write it is if then else of A, and then doing B of type bool, comma, X of type A, Y of type A. Okay, and that won't pass the test. There's nothing wrong with this. It works, right? It still captures the right meaning, but just because of the way we lay out the test and the form I ask you for, this isn't quite correct. So. Just know that they're equivalent types, but when Scala does type checking, they're not the same because it won't convert the two. That's all you kind of need to know there is it won't automatically convert those two types between each other. Any other questions about currying? There will be more practice with that on Monday, so just be on the lookout for that. Let's see, we did full, we did currying, we did the if then else update. We still have a lot of time left, so we will jump back into the PL stuff for the day. Where do I want to jump in? Yeah, so let's talk about interpreters. We talked about some inference rules yesterday, so I don't quite want to go grab them, but yeah, we won't go and grab them. But let's say I have these inference rules that I've defined that kind of give me an idea of how to define my language, and I want to implement them as an interpreter, right? So I don't know as though I think I've talked about interpreters. I don't know as though we've ever kind of formally defined what they are. They're the programs that run programs. Another way of saying this is programs are functions that evaluate expressions of a programming language. Okay. I say functions as well because we write programs as functions in this class, right? So what type will our interpreter have? So we can write this function as, we'll call it eval. And what type should it have? I already said it's going to be a function, so I'll throw the arrow in there as well. Yeah, it is a function type. What goes on either side of the arrow? We defined some types yesterday that might be useful here.
Yes.
Yeah, so expressions will be what we give as input, right? Programs, right? Expressions are programs. And then Ben says expression to expression, but I don't quite like that. When we evaluate something, what does it evaluate to? Yeah, a value type. Okay, so I think we called them vals yesterday. Is that the name of the type we said? Val or value, they're interchangeable. They're just name there. So expression to value, you could go expression to expression, but we don't quite want to do that because error is not part of expression. We need errors to handle minus and stuff like that. Okay, so now eval, how do we define something like eval? Now eval, it takes in some expression. What's its output? What's its output? Funny online, John says, for myself, usually an error. Yeah, so can we write an output for just any old expression, or do we need to probably case match here? Probably case match here, yeah. So what are possible cases? So let's just start by writing them all out. So we have what, nums? We have plus we had, what else do we have from yesterday? We had mult. What else do we have? And minus, is that all we did? Perfect. Cool. So if we evaluate, let's just go down the list, right? So these are all expecting values as outputs. So we're looking for either error or num_val. What does num_x evaluate to based on the inference rules we had yesterday? Okay, a num_val. What belongs in that num_val? Yeah, x here, right? Num_val x. And we'd expect it to, if I had an expression that was just a number, we'd expect it to be an x, right? How about plus? We had a few different inference rules for plus, right? We had like 3. So those are kind of different cases, right? How could we deal with that? So that's only if I don't get any errors, right? Yeah. How do I check that? Yeah, I have to evaluate them, right? So let's do that. Let's, eval E1, comma, eval E2, and let's match on that, match. This is a tuple. I'm already using our tuple notation. So tuples are really handy for doing matches if you have to match on more than one thing. You can actually match the tuple. So I have, say, a case here. What's one of my cases for that evaluation? One of the cases of interest. Yeah, so error is 1. Error for E1 or E2? Let's do E1. Yeah, so what should I put here? Probably just an underscore. I actually don't really care what the value of E2 is. What does that map to? Error. Cool. What's another case? Yeah, where E2 is an error. So I don't really care what E1 is again. I have an error here. What's that give me? Error. And how about my last case? Yeah, I have 2 num_vals, right? What does that result in? Yeah. Cool. And that plus is the plus, that function, that plus function we defined earlier. Whenever that was. Cool. Now, multiply. How do we do multiplication? How do we do multiplication? Yeah, so Brian says exactly the same thing, except we changed the function at the end. So I'm just going to copy all of this. And we're just going to change one thing. Duplicate. Yeah, and what do I change here particularly? It's that function at the end, that plus, will instead become multiply. And again, that multiplies that function you guys wrote. I think in homework 1, you wrote the multiply function, if I remember right. Cool, now let's get to minus. What about minus? Let's do a little bit more here. Yeah.
Yeah, probably the same first two cases, but then also a case when E2 is greater than E1.
Yeah, so we also have to kind of guard against the negative thing that's going on, because remember, negatives are an error case in this language. So we can duplicate the first 2 lines, so very similar again. But then for this case where we get number values, we also have to check that those values aren't going to give us a negative result. How do I do that check?
From the first 2 lines of that, we know none of them are errors. We could probably just send it to our less than or equal to.
Yeah, so we can do a less than or equal to. So I'll write in infix. Uh-oh. Uh-oh. Pen might have died again.
Doesn't let you.
No, this app doesn't for some reason. Actually, it might. Let me check. Bingo. I think that should do it. That won't let me open the notes back up. Oh, that didn't do it. Weird. Okay. Hopefully that got me enough charge though. So we're almost there. So we can do V1 less than or equal to V2. Is that the right order? Okay.
The V2 is less than or equal to V1.
Oh, so it's not the right order. Yeah, so it should be V2 is less than or equal to V1. And what should I do now? Yeah, I can match on this. Could also use that if then else function, right? If I wanted to. We're not going to do that though here. So I have a case for true. And a case for false. Sweet. If it's true, if V2 is less than V1, what do I get? What's my result? Cool, num val of minus V1, V2. And that's exactly the same minus that you guys wrote, right? You don't have to worry about the check. You know it's going to be a positive result. So you can just use the minus that we are implementing for this homework, for homework 2. And how about, oh, the other result for false? What if it would give us a negative result? What do we give? Yeah, we throw an error, right? Cool. Now, is that our whole interpreter? We just did it. Think you could implement that in Scala? Not really that bad. Just a few cases. You're just calling other functions that we've already written. You know, we're going to add to this. Don't worry. It's going to get complicated. But this is kind of the humble beginnings you guys will start doing on Monday to start a programming language. We'll get more complicated, but this is going to be our kind of beginnings. Yeah, famous last words. Anything else I want to remark on here? We could evaluate this. We won't because my pen's dying and we're wrapping up for the day. But otherwise, this is kind of what you're going to do on homework 3 is building out this first interpreter. There's a little bit more to do on it. I think you have to define all the types, I guess, because we haven't done that yet as well. There might be a few more things. So getting the grammar right, defining those for expressions and values, and then defining this function is the big stuff we're going to do for the next homework. Otherwise, are there any questions or anything I didn't cover that I said for office hour folks that I said I would today? I think I hit everything though.
I have just a question on if it would mess it up on the minus for the last match case for if you just said that is V1 greater than or equal to V2 and or some other way, but it basically will still give you the same thing. Like you needed one case to be the num val minus V1, V2. Like if you had it just reworded in a different way, but it will be the same thing, or would
So
that,
you
do you
could
need to have it like that?
flip these two. So you could have V1 go before V2, and then you'd switch your true and false cases.
Right. Okay. So that would be fine.
I do you? No, because 0 has, and it would 0 out, so it wouldn't matter. That being said, that's a good point. It's only because 0 is 0, right, that it would work here. If I were checking something else, I can't always flip stuff in my predicate here because the numbers are nice and symmetric like that. I can't. So good question, Rose. Yeah, it's just kind of switching operators around, then you flip the true and false. So there are plenty of other ways. If you had a greater than or equals, which I don't think we have implemented, you could use that too. Yeah, so there's some options there. Sweet. Well, I'll turn you guys loose for the weekend. I'll hang out for a few minutes if you guys have questions. Otherwise, have a great weekend. Be on the lookout for some writing posted tomorrow and that addenda with the new standard lib. And the homework, will be due Monday night. So yeah, be on the lookout for that. Or we'll be due Monday, I guess, before recitation, not Monday at midnight, I should say. Wait, yeah, well, no, it'll be Monday at midnight. The new homework won't be out until after the old homework's due. That's what I got mixed up. Monday on midnight, the homework 2 is due. Cool. Thank you for that. Sweet. Thanks, John. Thanks, Noah. Have a good one, guys.